Hey YouTubers, welcome back again, and we're gonna do another example of stoichiometric reacting masses, okay? And now we're gonna take 20 grams of the same sodium hydroxide, but now we're gonna react it with excess amounts of sulfuric acid. We're gonna get sodium sulfate and water. Then again, write and balance the equation, okay? So we have NaOH reacting with H2SO4 to give me Na2SO4 plus H2O. So, how many balance the equation? There you go. 2 moles of sodium hydroxide will react with 1 mole of sulfuric acid to give me 1 mole of sodium sulfate and 2 moles of water. Okay, so how many moles of sodium hydroxide would I have? Well, again, using this mass triangle relationship between mass and moles, I would say that I have 20 grams over 40 grams per mole of sodium hydroxide, which gives me 0.5 moles of NaOH. Perfect. So, how many moles of sodium sulfate did I make? Well, let's look at the molar relationship between sodium hydroxide and sodium sulfate. The relationship is a 2-to-1 relationship. So if I had 0.5 moles of sodium hydroxide, I should have half of that, which is 0.25 moles of sodium sulfate. Okay, that's what I should have. Now, how do I get the grams of sodium sulfate? Well, I'll take this formula again and I'll measure the mass, which will give me moles times the molar mass. Okay? The moles is 0.25 gram moles, alright? And the molar mass is 142 grams per mole. Now, how do I get 142? Well, let's take 22 times 23 plus 32 plus 4 times 16. And that should be 142. That is the relative mass or the molar mass of sodium sulfate. Okay, punch that into my calculator. I've got 142 multiplied by a quarter. Boom, it's 35.5 grams of sodium sulfate. Alright, so again, now you see the difference between this example and the previous example, where the molar relationships of what we're trying to solve is different. All right. In previous example, we have 1-to-1. Now we have 2-to-1. And so the thing that has changed here is this 2-to-1 relationship. And basically, you need to know the balance equations to figure out this molar ratios, because in reality, when you're given 0.5 moles of sodium hydroxide, you will only get 0.25 moles of sodium sulfate. And that's the gist of it. So, to really summarize this whole learning relationship of stoichiometric reacting masses, we can think of it conceptually by using a concept map. So, conceptually, if we're given the mass of A, okay, mass of substance A, we need to figure out the moles of that A, substance A. And we do that by using the periodic table to figure out the relationship, the periodic table, to convert from mass to moles. And then we need to convert the moles of the substance A to the moles of substance B. Okay, so whether this B is the other reactant or the B is the product, it doesn't really matter. So we get this mole-to-mole relationship by what we call the mole ratio. So you have to know the ratio between A and B. And you get this ratio initially from the balance equation. Okay, so you got to know how to balance equation, guys. Okay, and so when we solve for this guy, we can go back and figure out the mass, because in the real world, you can't measure moles. You can calculate moles, but you can definitely measure mass. And when you measure this, and then you calculate this mass that you have, that you should get out of the reaction. All right? So there you go. This is the concept map of the mass of A to get the moles of A, to get the moles of B, to get the mass of B. Peace.